You know, we have to have a shout out to Will Banks. Hey Will, there's a shout out to you. I hope you're not too sick, and then you're not like that. You're not like that baby pony, because he was a little horse.
Oh my God.
Okay, that's enough. So surface area is what you get when you add all the sides up together, right? And so I think you can figure that out pretty much on your own, but I'll draw some shapes. Ooh, in my gallery, I think I have some shapes. Wait, I'm gonna have to pause, because where's my recorder go? Where's my recorder go?
It's like,
Oh, it's down here. Okay, time to start, guys. All right, so this, if you know or may not know, this is called a rectangular prism, okay? And to find the surface area, you just add together all the faces. So even though it looks, this thing looks symmetrical, like this is a square, well, maybe I could stretch it. There, now it doesn't look like a square anymore, okay? So say this is 5, and this is 4, and this is 8. Could you find the surface area of that figure? Okay. So all you have to do is, there's a couple different ways to do it.
Are we recording now?
I'm recording now. Okay. But you just add up all the sides. It's one way. And so you'd have 5 times 4 for the front and the back. And how many of those pieces do I have? 2 5 times 4s. And then I have this face, which is what?
8 by 4.
That's 8 by 4, and I have 2 of those. 2 8 by 4s. And then I have a top and a bottom, which is what?
12.
8 by 5. And I have 2 of those, which is 8 by 5. And then I add all the pieces up, and I get my my surface area, right? You can do that, right? So that's 2 times 5 times 4, which is 40. And 2 times 8 times 4, which is 64. And 2 times 8 times 5, which is 80. And then you add up all the pieces, and you get 184?
yeah.
184. And if your units are in feet or something, that would be how many square feet of paint you need to paint your bedroom or something, unless you're not painting the floor, which you wouldn't probably do. Okay? So that's surface area of a rectangular prism. That's pretty easy, right?
Yes.
Okay, good. Let's move on to one where you have something a little more complicated. Say I were to have, what if I had something that looks like this? Ooh. Okay, which is, and let's say that this is a regular hexagonal. So this is a regular hexagonal prism, and basically instead of adding each face up individually, what I could do is take, if I unwrapped it, right, I would get like 6 equivalent sections. Do you see that? 1, 2, 3, 4, 5, 6?
That's 7.
7, okay. 7, I'm going kind of fast here. And this is the perimeter of that figure. Yes? So you have the perimeter times, what would you call this?
Height.
Times the height plus 2 times the base. Okay? So the area for any regular, well, for any prism, in fact, is the perimeter times the height plus 2 times the base. And the base, what I mean by B, that's the area of the base. So, for instance, say you know that this.
Can you say that again?
So the perimeter times the height of the prism, okay, plus 2 times the base, where the base is the area of the 2 congruent sides. So this is for any prism, in fact, okay, for surface area for a prism, for a surface area for it would really be for only a right prism, meaning it's not leaning over on its side like oblique. So it's the perimeter times the height and times 2 times base. So for instance, say I know that this is 10 and that one of these pieces side lengths that it's regular, meaning it's all the pieces are the same, okay? And that's 10. And then what would I need to know to calculate the area of the base of this? What would I need to know in addition to what I have so far? What do you call this piece that goes from right there to there? The apothem, okay? So apothem, no, apothem is it's a little furry animal with a lip that crawls around in the night time. It has that very big teeth and a long nose. An apothem. But an apothem, that apothem, that is the height to this side. So say I know that this is 5.1 and this is 6, then I can find the area of this by going the perimeter, which is 6 times 6, 36, times the height, which in this case is 10, plus 2 times the area of the base is 1/2 the apothem, which is 5.1, 1/2 A times N, which is 6, times N, which is also 6, okay? Do you guys understand what I just did?
No.
Okay?
Not really.
This is the perimeter. This is the height, if I were to put it on its, if this is the bottom and this is the top, okay? This is 2 times, and the way you find the area of a regular hexagon is 1/2 A N S, where N is the number of sides, and S is the length of the side, okay? Yes, ma'am?
So you're finding the area of the regular polygon and then just putting the others.
And then well, this is the area of the 2 regular polygons, and this is the area of the sides, right? If I unwrap it. Okay. So when you think about this, you don't want to just plug into a formula. You want to kind of think about things before you do it.
Wait, so you
Okay?
find the
Wait, how did you get the
How did I get the perimeter?
Yeah.
6 sides, and I told you that the length is 6, right?
Oh,
Okay.
but there's
So 6 times 6 gives you 36. 36 times 10 is 360. 2 and 2 cancel out. 5.1 times 6 is 30.6 times 6 is 100 and what's 30.6 times 6? 131.6? 131.8, I believe. And then I add all that stuff. Did I do that right? 181. Thank you. I knew that. Is it? 183.6. Okay. And then I add those all up and I get the answer. Okay? Question?
I have a question.
Tessa, what are you doing? Yes?
She was serious.
She was trying to kill it. When you got the 36, I only from 1.
Okay. So we're recording again. So this is a cylinder, and if you can think about it in the same way as you think about a prism, okay? This is the radius, right? Or the radius is down here. And if I unfold this cylinder, okay, I have the perimeter in a cylinder is what? What's another name for the perimeter of a cylinder? The circumference. And that's the way to find the circumference is 2 pi r, right? Yeah? Okay? And this is just the height of that cylinder, right? So far, I have 2 pi r times h, right? Which would give you that's called the lateral area, the area of the sides. 2 pi r h, that's called the lateral area. Whoops, I'm not recording, am I? I'm recording, okay. That's called the lateral area. And then I have to find the area of the 2 bases. Well, how do I find the area of the 2 bases? And how many do I have? 2 pi r squared. So to find the surface area in a cylinder, so say this radius is y, and the height is 10. All I have to do is plug into this formula, and I get 2 times pi times 5 times 10 plus 2 times pi times 5 squared. Okay? You follow? Which gives you 50 times 2, 100 pi plus 25 times 2, 50 pi. Altogether, how much pi is that? 150 pi's. And if that's in inches or meters squared, so say that's meters, so that would be in meters squared. So that would be the total surface area of your cylinder. So this is the base area, and this is the lateral area. Okay? You got that so far? We're good? Okay. We're going to talk about a prism now. Can I move on? Okay. To a... That's not a prism. Is this a prism? Kind of a prism. Pyramid, I mean. Okay? So, next one we're going to talk about is a pyramid. Oh, that's not a very good pyramid, but it's a pyramid nonetheless. And if I took this pyramid and I were to draw a line down here, this line from here to here, this is the height of one of those.
So that's the apothem.
It's not called the apothem. This has a name, and this is called the slant height. Okay? Slant height versus the height, which is going straight down the middle. So if I were to do the regular height goes straight down the middle, and it's at a 90-degree angle to the bottom. Do you kind of? That would be the height of the pyramid, where this is called the slant height. And those are actually related. If I were to draw in another triangle, right, make this triangle, how would these three lengths be related? This, this, and this?
They're all shaped.
By what? The something theorem. By the Pythagorean theorem, because this makes a right triangle right there. You see that? Okay? So, but if I unfolded this thing, let's see if I can kind of draw a picture of this. But if I unfolded this, there's a square, and then I have a bunch of triangles. Let's see if this works. Oh, look at me go. It's not going to work, right? Did it work? Oh, it worked. Okay, it's working. Okay. So if I unfolded this, do you see that I get this thing in 4 triangles? Yes? Okay. But basically each one of these is base times height divided by 2. Right? Each one of those triangles. So if I want to find the total surface area, I'm going to take the base, okay, plus this, plus this, plus this, plus this, divided by 2 times the height, okay? What's this plus this plus this plus this called?
Square.
What's the distance around something called? That's the perimeter. So it's pi. Oh, and the letter they use for the slant height is L. Okay? So it's B plus P times L divided by 2. Okay? That's the area for the surface area of a right pyramid. Okay? Right pyramid meaning it's straight up and down. Yeah? And it's symmetric. It's got to be symmetric all the way around. So say this is 6. Now let's not always use 6. Let's say that this is 8. They tell you this is 8. They tell you this is 8. They tell you this is here. That's, I don't know, 9. And they tell you find the surface area. Could you do that?
Wait, which one's 9?
The slant height is 9.
Oh.
So you just plug in. What's the area of the base? 64. So you would have 64. What's the perimeter? Also 64 times the slant height, which is 9, divided by 2.
64.
8 plus 8 plus 8. right?
That's
What's
what?
8?
That's
That's
32.
Oh, I knew that. I was just testing to see if you guys were still awake. Okay.
What?
32 times, sorry. That's what happens when I make up problems as they go. Okay, 32 plus 16 times 9. What's 16 times 9? 144? Yes, 144. Okay, which gives you 208. Is that right?
Yeah.
208 square units. So those are in skunits. Skunits. Whatever the units happen to be, square units. Okay, skunits. Okay, last formula that you're going to have to know is for a cone. Okay? And so a cone, done. Cone, ice cream cone, vanilla flavored
Always a
cone.
cone.
This kind of cone looks like that. Okay? Cone. Alright? So a cone, in a cone, this is also called the slant height. This is called the height of the cone. This is called the radius of the cone. And if I took the circumference, I just want to show you where this formula comes from. What is the circumference of a circle? So if I use the same formula, it'd be the area of the base plus the perimeter times the slant height divided by 2. This can be thought of as a bunch of triangles, infinitely many triangles added up, okay? But, whoops, plus, not equals, okay? So what's the area of the base in a circle? What's that area? Pi r squared. The perimeter is 2 pi r, right? L is just L, and I'm going to divide that by 2. So these go away. And I get the formula for the area, the surface area of a cone is equal to pi r squared plus pi r L, where this is the base, right? And this is the lateral area. So if they ask you, find the surface area. Oh, here's a good one. Say this is 4, and they tell you this is 3. That can be. Let's call this 3 here. Let's call this 3 and this 4. And they said, find the surface area. Whoops, sorry. Oh, it's just your back. Can I do that? How can I find L? How are these related? You guys remember? Hypotenuse a squared plus b squared equals c squared. Remember that? We haven't really done the Pythagorean theorem chapter yet, but I think you remember that 3 squared plus 4 squared equals L squared. Do you remember that? Yeah. So 9 plus 16. This is like the kind of problem they love to give you on TCAPs and stuff. 25 equals L squared. So what's L equal to? L equals 5. Okay? So if this is 5, then I could plug into this formula. Pi times what squared?
R.
R is 3 plus pi times R again, which is 3, times L, which we just discovered is 5. And if I do that on my calculator, I get 9 pi plus 15 pi, which comes out to be 24 pi. Exactly. It's a lot of work. So you should be writing down all those formulas. Area of a pyramid, area of a cone, area of a cylinder, area of a regular prism, okay, and so on. Just don't be. 1 second. I'm not done yet. We got some time. Don't get too hung up. Don't get too stuck on the formulas. Because say I have a figure, which you will, that looks like, let's see if I can do this. Make this go with this. Make it a little smaller. Whoa. Isn't that a bit?
way.
Yes, way. Yes, way. Okay. So say I have a figure that looks like this, right? You would be, and they say find the total surface area. Okay? Surface area equals, which you will, and you will see this on a test, I promise you. Okay?
Rocket right there.
Right, like a silo or a rocket or something like this. the area of this is 2 times the area of the base, okay? Plus 2. So this would be 2 times the base area plus 2 pi RH plus the area of the base plus the base plus pi RL. Because this is the cone here, and this is the cylinder here. Who can tell me what's wrong with this? What's wrong with that, Sophia? Right, because this base you never see, right? If I were just finding the surface area. So all I have is one base altogether. So if I were finding the formula for this thing, you got to think a little bit. It'd be pi r squared plus 2 pi RH, because you do have this base down here, plus 2 pi RH, which is the surface area of this thing, plus pi RL, which is the lateral area of the cone. So you got to make sure that you know what you're looking at when you have a problem, okay? So you're not just blindly plugging into formulas to figure out the answer. Follow that? Okay? So, your homework is page 466.
The whole page?
1 through 11. That's it. Okay? And remember, you heard it here on Mr. Leader's cutting edge, leading edge geometry channel. Okay. Goodbye.
Well,
Bye, Will. Hope you feel better tomorrow. You're probably asleep now, aren't you?